Gravel is being dumped from a conveyor belt at a rate of 30 feet cubed per minute. So here's the conveyor belt, and the gravel is being dumped into the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? So the rate at which the gravel is being dumped, or the rate at which the volume is increasing, is 30 feet cubed per minute. And the height is 10 feet, and we're trying to find the rate at which the height increases. The formula that we're going to use is the volume formula for a cone, which is volume equals 1/3 pi r squared times height. But we don't know what r is, or we don't have dr of dt. So we have to substitute something for r. So the radius is just going to be half of the height, because the height and the base are equal to each other. And the radius is just half of the base. And we can just plug that back into our volume equation. So we have volume equals 1/3 pi, and then 1/2 h squared times h. And we can simplify that to volume equals 1/12 pi h cubed. And we can take the derivative of that with respect to time. So we have dv over dt equals 1/12 pi, which is just the constant, and then the derivative of h cubed, which is 3h squared times its chain rule component. And this is just 1/4. And so to solve for dt, we can multiply the 4 over and divide by pi h squared. And then we can plug in 30 for dv over dt and 10 for h. So that equals 4 times 30 over pi 10 squared, which equals 120 over 100 pi, which equals 6 over 5 pi. And to figure out the units, we have dv over dt, which is feet cubed per minute, over height, which is in feet, but it's squared, so feet squared. And feet cubed per minute divided by feet squared gives you feet per minute. So the height of the gravel pile is increasing at a rate (6/5 pi feet per minute.